So here we need to find the equation of this exponential function. We recognize that it's an exponential function, which means the general form is k times a to the x plus c. Now, one of those we can see immediately because we can see that the asymptote coming through here is at y equals 2, which means that this is going to be plus 2 on the end to indicate that. We still don't know k or a. We have two unknowns, but fortunately we have two pieces of information, two coordinates. So we're going to substitute in our two coordinates, and from there we can work out the values that we need. So when we substitute in 1, 3, we get 3 is equal to k times a to the 1, and then plus 2. And when we substitute in the other point, 2, 5, we get 5 equals k times a squared plus 2. Rearranging each of those a little bit, we get ka is equal to 1 and ka squared is equal to 3. Now dividing through this bottom one by this top one, we're going to end up with ka squared over ka equals 3 over 1. So a is equal to 3. Now we found a. And once we know a, we substitute that into this equation here because we know that 3k is equal to 1, which means k is equal to 1/3. So the equation is going to be y equals 1/3 times 3 to the power of x plus 2. Notice that we use the asymptote to find one of the unknowns and then set up a pair of simultaneous equations that we needed to solve to find the other two unknowns. That's a very common approach to solving these kind of problems for multiple functions, not just exponential functions, where you have to use a factor that you know to determine one of the constants and then use 2 points as simultaneous equations to find the other two.